Okay, so in this lesson, we're going to look at graphing a log function that has this form and only this form. So we're looking at y equals the log base b of x, or the log of x base b. So for example, look at number 1. So this is what it will look like. F of x equal the log of x base 3. So always make sure your base looks like a subscript. So the log of x base 3. A couple of things I remind you about your base, and that goes back to an exponential. So when we talked about an exponential, we said that the base must be a positive number and the base cannot equal 1. Okay, so the same thing is true with a logarithm. The base must be positive and the base cannot equal 1. So always make sure that's the case. So the base is positive and the base is not equal 1. Okay, so remember in a logarithm, so first of all, the exponential is 1 to 1, right? So a logarithm is also going to be 1 to 1. So its inverse will be 1 to 1. So notice it is a 1 to 1 function. And the other thing I want to remind you is that a logarithm always has a vertical asymptote. So remember, an exponential has a horizontal asymptote. A logarithm is going to have a vertical asymptote. And then the question to you becomes, well, how do you find that vertical asymptote? Well, it's pretty easy to find the vertical asymptote. So we're going to find the vertical asymptote. To find the vertical asymptote of a log function, all you do is this. Take the argument. We're going to call what we're taking the log of the argument. Take the argument, which in this case is just x. Take the argument and you set it equal to 0. Always set it equal to 0. And so the argument is x, so I get x equals 0, and you solve for x. Well, I already solved for x. So there's your vertical asymptote. So the vertical asymptote is x equal 0. So when you start graphing this, you're going to graph the vertical asymptote. So it looks something like this. So remember, we're going to graph y equals log base b, y equals log base 3 of x. So the vertical asymptote is going to be the y-axis, x equals 0. Okay? All right. Then what we're going to do, or what we have to notice also from our previous discussion, is that a log function always crosses the x-axis. Always crosses the x-axis. So there's always going to be an x-intercept. So let's find the x-intercept. All right, to find the x-intercept, remember from previous lessons, to find the x-intercept, you let y equal 0, right? So I'm going to go back, I'm going to set my function equal to 0. So this is y, so I'm going to set this equal to 0. So I get log base 3 of x equals 0. All right, you got to solve for x. Now you all know how to do this because in a previous lesson, you learned how to write a log equation to an exponential equation. So here you're going from a log equation to an exponential equation. And remember how to do that, how to write a log equation into an exponential equation. So first of all, you take the base, which is 3, and you raise it to that number that's on the other side. So you're going to say 3 to the 0. And that's going to equal the argument, which is x. Well, 3 to the 0 is 1, so 1 equals x. So there's your x-intercept. So the x-intercept is 1. So the x-intercept is going to be 1, 0. So that means here you have this. You're going to plot the point 1, 0. Okay? Now, what we're going to do is we're going to notice this. I want you to notice this. I need another point. I need another point to help me graph this. Now, one thing I want you to remember is that the base is 3, right? So the base is 3. Now, remember when we dealt with an exponential function, we in one of our lessons a while back, we saw that if the base is greater than 1, it's an increasing function. If the base is between 0 and 1, meaning a proper fraction, it was a decreasing function. Remember that? So I want you to notice that here, my base is 2, so that's greater than 1, so my function is increasing. The same thing is true with the exponential. It was increasing as well. So if the base is greater than 1, your function is going to increase. If the base is a proper fraction less than 1, the function will decrease. So I want you to notice is that here, since my base is 3, since the base, which is 3, is greater than 1, the function increases. So the function increases, meaning my y values are going to get bigger and bigger and bigger. That's what that means. So what that also means then is that my graph on this side gets closer and closer to the vertical asymptote. That's what that means. So I need another point here to help me, though. I need one more point to help me graph a sketch of this function. And here's what you do. And that brings us back to a lesson we learned previously, and that's this. So to find one key point, find a key point, here's what I would do. You see the base is 3, right? The base is 3. So what I would do is I would let x equal the base, which is 3. And so let x be the base, which is 3, and then find y. All right, so I get y equals the log base 3 of 3, right? Log base 3 of 3. Well, you learned something about this. So if I convert, I want you to think about this. If you could do this one of two ways. I can rewrite this as an exponential equation like I did before. All right, so I know as I can say the base raised to this power, so 3 to the y equals 3, and then I can look at what I have. 3 to what power is itself? So 3 to what power is equal to 3? Well, this is true if y equals 1, right? So 3 to the first equals 3. So you learned that a property you learned was this. Whenever you have the log of a base, b, the log of b and the base is the same, then you know that's equal to 1 because b to the first equals b. So in other words, you also learned this. You learned very quickly that if you have the log of 7 base 7, you know that's 1. 7 to the first equals 7. The log of 6.2 base 6.2 equals 1. So you learned in a previous lesson that whenever the argument and the base are the same, then the log of that number with that same base is equal to 1. All right? So the key point you should always use when it's in this form right here is to let x equal this base. So whenever x is equal to the base, my y value will always equal 1. Okay? So a key point you found is this. You let x be, what, 3? So you get 3, 1. And then you got to plot that point, 3, 1. Watch how simple this is. 3, 1, which is here. And then you do this, and you're done. Okay? That's all you have to do. So there's the graph. Now, if you want to, once you learn about, I'm just going to say this, once you learn about change of base formulas, then you could go ahead and use your calculator to find more points. You can use your calculator to find more points. But for right now, you haven't talked about base change formula. So I'm going to keep it like this for right now. Okay? We haven't learned about base change formula yet. But once you learn about the base change formula, and I'll write it here, the base change formula can help you find more points using a calculator. Okay. Now, just to kind of tell you something else here, and I want to show you this. If I let the same problem here, but if I let x equal 9, you have enough information from a previous lesson to help you find the y value. If x equals 9, find y. All right, so here's what we have. We have y equals the log of 9 base 3. Okay? Well, what that means is this. 3 to what power? 3 to what power equals 9? Well, 3 to what power is 9? 3 squared is 9, right? So y equals 2. So y would be equal to 2. So what you found is another point. You found another point to be 9, 2. That's what you found. So in other words, right here, you would get another point, y 9, 2. All right? So just letting you know that if these numbers here are not, the bases here are not difficult, then you could also find maybe 1 or 2 other points. But if you know the base change formula, that can help you to actually find more points because you're able to use your calculator. All right, so there's the graph of the y equals the log base 3 of x. All right, let's look at another one. Before I go on, I want you to notice that this function here, that's in this form, there is no y-intercept, right? So I wanted to make a note that there's an x-intercept. You're always going to have an x-intercept because every logarithm crosses the x-axis, but there is no y-intercept. I want you to notice that. So hopefully you see this. The graph is never going to cross the y-axis because the vertical asymptote is the y-axis. Okay, so remember we drew that earlier, the vertical asymptote. So there's no y-intercept there. We also know that this function is increasing. Okay, so I want you to realize that function's increasing. Increasing function. And the reason it's increasing, you could tell from the beginning because the base is 3. So the function's increasing since the base is greater than 0. 3 is greater than 0. Okay? And then we know that the domain is, let me get my ruler so I can show you. The domain from previous examples in another lesson, we know this is going to be from 0 to infinity. Domain 0 to infinity. And we know the range of all logarithms, is going to be all real numbers. So the range is all real numbers. Okay, all real numbers. And it kind of makes sense because when you looked at an exponential, all right, when you looked at an exponential, let me go ahead and quickly find my function. When we looked at an exponential, right here, the domain was all real numbers. So the domain of an exponential, remember, becomes the range of the logarithm. So if the domain of an exponential is all real numbers, then the range of every logarithm will be all real numbers. So that's what you see here. Okay? So the range is all real numbers. Okay, so that is the first one. Let's look at another one. Okay, so now we're going to graph the log of x base 1/3. Now, in the previous problem, we saw that my base was 3, right? Since my base was greater than 1, we knew that my function was going to increase. It was an increasing function. We also know this, that if the base is less than 1, like this one is, since the base is less than 1, one-third is less than 1, the function f of x is a decreasing function. Okay, decreasing function. So you're going to see that when we look at the graph. All right, so just like we did before, we're going to find the vertical asymptote. So find the vertical asymptote. And to find the vertical asymptote, which you probably already know what it is already, but to find the vertical asymptote, we take the argument and we set it equal to 0. So x equals 0. Take that argument, set it equal to 0, and solve for x. Well, x is already by itself, right? So there's the vertical asymptote. There's always this argument equal to 0, solve for x. But if this is just x, then your vertical asymptote is x equals 0. And so when we draw the line y equals 0, that happens to be, x equals 0. When we draw the line x equals 0, that happens to be the y-intercept, the y-axis. The y-axis happens to be the y-axis. So there's your vertical asymptote. Okay, so we're graphing log of x base 1/3. All right, So that's the first thing we did. Then we're going to find the x-intercept. So remember, a log function always crosses the x-axis. Always crosses the x-axis. So we're going to find the x-intercept. All right, now just remember, just like you did before, to find the x-intercept, you're going to let y equal 0, right? So I'm going to set this equal to 0. Y is equal to 0. So I get log of 1/3 log of x base 1/3 equals 0. And so now what we're going to do is we're going to change this to an exponential equation. So we change this to an exponential equation. And so to change that to an exponential equation, you take the base, which is 1/3, and you set it and you raise it to this exponent right here, 0. And that's going to equal the argument, which is x. So 1/3 to the 0, which is 1, is equal to the x-intercept. So the x-intercept is 1. So it's going to be 1, 0. So I know this. I know that the log function here is going to cross the x-axis at 1. Okay? And then I need another point. So remember we said we always to find that key point, let x equal the base, which in this case is 1/3. So if I let x equal 1/3, I get this. I get y equals log base 1/3 of 1/3. So I know that if the argument and the base are the same, 1/3 to the first power equals 1/3, right? So if those two are the same, then the log of that with that same base equals 1. So one of my key points is this then. One of my key points is 1/3, 1. So x is 1/3, y is 1. Meaning that 1/3 is about here. So this is 1, 1/3 is about here, and here's 1. And let's go ahead and so the problem is that you really don't know how to use the base change formula. So all you can do at this point is kind of draw something like this for right now, and then it goes away from the from the vertical asymptote like that. Okay. All right. So that is the graph of y equals 1/3 x. I'm sorry. That is graph of log of x base 1/3. Excuse me. Log of x base 1/3. All right, so let me see if I can without using the base change formula, if I can explain to you how to maybe find one more point. So let's talk about finding one more point without knowing something about the base change formula. Okay, so what I want to do is show you this, and maybe you'll understand where I'm coming from. And I'm going to start with 3 first. I'm going to let x equal 3. So if I let x equal 3, I get this. I get y equals 1/3 the log of 3 base 1/3. Okay? And so I know this. I know that I can write this as an exponential equation since that's a log equation. So I'm going to take the base, which is 1/3. I'm going to raise it to the y power, and that's going to equal 3. Okay? All right, now listen carefully. So I know that 1/3 from previous lessons, I know that that's the same thing as saying 3 to the negative 1 power. So I'm going to replace this 1/3 with 3 to the negative 1. So I get 3 to the negative 1 raised to the y power equals 3. And I know from a previous course that when you have an exponent raised to another exponent, you multiply those exponents. So negative 1 times y is a negative y. So get 3 to the negative y is equal to 3. Okay? And notice that those two bases are the same. So if 3 to the negative y is equal to 3 to the first power, then that means that negative y has to equal 1. And so if I solve for y, I'm going to go ahead and remind myself that negative y means the same thing as negative 1 times y. And dividing both sides by negative 1, I get y to be negative 1. So when x is 3, my y value is negative 1. So when x is 3, my y value is -1. So now I'm going to plot that point, and I didn't do a very good job with this one, did I? So 3, -1's right here. So let me go ahead real quickly and erase that part. Now, if you had left it like this, that's fine, because we hadn't really talked about base change formula at this point. But to draw a little bit better, if you know enough of this, you can go ahead and plot some points, a few more points. So 3, -1 is right here, okay? And then you could do the same thing with if you let x equal 9, let's say. So if I let x equal 9, I get this. I get log of 9 base 1/3, okay, equal y. And then changing this to an exponential equation, I get 1/3 to the y equals 9. And just like we did a while ago, we know that 1/3 is 3 to -1. So replace 1/3 as 3 to -1. Raised to the y power equal 9. And then -1 times y is a -y. So 3 to -y equals 9. And then I want you to notice something. You see this 9 right here? I can write this 9 as 3 squared. So get 3 to -y equals 3 squared, right? So now notice the bases are the same. So that means that those exponents have to be equal. So -1y has to equal 2. And dividing both sides by -1, I get y to be a -2. So I get another point, 9, -2. So I'll plot that point, 9, -2, which is about here. So if I wanted to draw this a little bit better, I would get something that looks like this. Okay? But just to let you know, if you had done something like this, make sure that this part goes towards the vertical asymptote and this part goes away from it. All right. But to make it much better, it's always a good idea to plot more points. But for right now, you really don't. All you really know how to do is basically plot 2 points. Once you learn about the base change formula, then you'll be able to draw better graphs for this. All right? Okay, so that is a couple of problems I wanted to show you about how to graph log functions of this form. A couple of things I want you to remember is that if the base is greater than 0, your function is increasing. You'll see it increases. If the base is if the base is greater than 1, your function is increasing. If your base is less than 1, between 0 and 1, your function decreases. So 1/3 is less than 1, it decreased. Right here, 3 is greater than 1, your function increased. Okay? All right, so I think that's all I wanted to do. I just wanted to do 2 problems here just to show you how to graph something that looks like this form. For right now, all you really know how to do is maybe plot 2 points. Some of you may know a little bit more in terms of being able to plot 1 more point, but we haven't talked about the base change formula to be able to, we haven't talked about this yet, to be able to plot more points to draw a better graph. But that's about all you can do at this point.